Yeah, Jai Hind all. Myself, Dr. Sachin Kumar, working as a professor at Ajay Kumar Gar Engineering College, Ghaziabad. So today we are going to discuss about the very important topic that is related to the operating system, and the topic is process state and performance criteria for CPU scheduling. Ultimately, we have a number of processes, and all the processes come into memory from hard disk for the execution purpose. And when process is on the RAM or main memory, then processor can execute that process. Nowadays, we people are living in the era of multi-programming operating systems or multi-core processors concepts. So we have the multiple processes in the memory, and at the same time all the processes are running. So therefore, we need the effective CPU scheduling algorithm to execute that processes, and the selection of the CPU scheduling depends upon the performance criteria. So based on the performance criteria, algorithm is evaluated, which one is better, which one is good, or which one is the best. So we have here 5 performance criteria that we are going to discuss in this particular video, and at the same time we also need to learn or understand the concept of the process state. Since process has multiple states, so when process comes from hard disk to memory, then process has to pass from several states. So what are these process states? What are the reasons to divide the process into multiple states? What are the benefits? What is the sequence to execute this particular states? So we people are going to discuss these concepts in this video. So now when we talk about the process state, to understand the process state, I have mentioned the diagram. From this diagram, we can easily understand what are the several states are involved to execute the process. So first one is the new state. After that, we have the ready state. From the ready state, process may go to the running state, and from running state, process may back to ready state, or sometimes may not back. After completion execution of the process go to the terminating state, and process from the running state may come to the waiting state, and from the waiting state process may go to the ready state, and finally process may go to the running state or terminating state. So n number of cycles may be possible, and sometime only in one go, only in one cycle process may be executed. So what are the these states? We are going to discuss the concept in detail. So first of all, when we talk about the process is in hard disk initially. So when process wants to execute from hard disk, then it comes from hard disk to memory for the execution purpose. And for the better understanding, when any process is in hard disk, it is called the program. When this particular program comes from hard disk to main memory, then it is termed as the process. So we have to know the difference between these two, program and process. Program means in hard disk and process means in main memory or RAM. So we are talking about the scenario of the main memory when process is in the main memory. Fine. So here, when process comes from hard disk to memory, then we can term as this is in the new state. And after new state, after new process is new, then process is admitted and now process is the RAM. Initially the process is new, and after admitting the process, admitting means we have taken the decision this particular process should come from hard disk to RAM, then process has been admitted, and after admitting the process is in the RAM. Process is in the ready state. Ready state means process is in the RAM, but still processor or CPU is not assigned. This particular process is waiting for the CPU. Therefore, process is in the ready state. Since we have the concept of the multi-programming system, our processor may be busy to execute some other process. So therefore, previous process in the ready state. After after some time, processor may be free, then process will execute that process. Otherwise, that process will remain in the ready state. The point is very simple. Whenever any process comes from hard disk to RAM, then initially process is counted in the ready state. So ready state means this process is waiting for the processor. Now, after passing some time, say few milliseconds, now CPU is assigned. Whenever CPU is assigned to the process, to that particular process, then process comes from ready state to running state. So now process is in the running state because CPU has been assigned, and now CPU is working on that process. CPU is running that process. So therefore, process is in the running state. And suppose process runs successfully, nothing major incident happen on that particular process, then after completion of that particular process will be exit and it goes into the terminating state. So it may be the first possibility. I mean, from new to ready, process in the RAM, and now CPU is assigned, process is the running state, and after running state, process has been completed and we are at the terminating state. So this is the one possibility. Second possibility may be that process is running here and we have here say some interrupt, then that particular process switch comes from running state to ready state, and after working on the interrupt, this particular process comes from ready state to running state. So it simple means that if interrupt has been occurred, then we need to switch the process from running to ready state. Reason is very simple. This particular process is waiting response from the interrupt, and at the same time we want to use our CPU. So our CPU can run another process. So therefore, we need to switch the previous process after occurring the interrupt from running to ready, so that CPU can be utilized perfectly. So this is the reason to come the process from running state to ready state, and after servicing this particular interrupt, getting the interrupt, then process comes from ready state to running state for the execution purpose. And third scenario, when process is in the running state, it may be process may need input output operation. For example, if we talk about the C programming language, then our program may have several scanf instructions, So when particular process is waiting for the input operations or sometimes output operations, then process comes from running state to waiting state. Reason is very simple, because process is waiting for the input output, and at the same time there is no benefit to focus of CPU to that particular process. It is the misutilization of the CPU. It may be the misutilization of the CPU. Therefore, we need to change the state of the process. If any input output operation is there, process comes from running state to waiting state. This is the reason for maximum utilization of the CPU. Now, process is in the waiting state, and after serving the input output operation, now process comes from waiting state to ready state. Now this particular process has the input, whatever the input process wants. Now it has. So further process waits for its turns. Whenever turns come, process comes from ready state to running state. And at the running state, remaining part of the process is running. And whenever you have the one more scanf instruction, then process once again comes from running to waiting state, and after supplying that particular input output, process comes from waiting to ready and ready to running. So there may be multiple cycles. So it depends upon, nature of the instructions, what kind of instructions you have in your process. And once your program is finally executed, then from running to exit. So here, this is the scenario of the multiple states, how processes are executed and how several states of the process works. So we see here mainly two sequences. First sequence is here from new to ready, ready to running, then terminated. If we have the sequence like this, I'm further repeating, if we have the sequence from new to ready, ready to running, running to terminate. So it means that particular process has been executed in one go. No need of any cycle to execute the process. If you have a cycle like this from new to ready, ready to running, waiting for the input output, then further ready, running, waiting for input output, ready, running. So we have here multiple cycle and finally terminating. So if in one go means from new to ready, ready to running, running to terminating, then process is running in one go. And second scenario may be the multiple cycle. So when we have the one go concept, process is running in one go, then you may term as the non-preemptive CPU scheduling algorithm. In one go, non-preemptive. And when you have the cycle like this, then you have multiple cycles to execute the process, then such algorithm is classified under the preemptive concept. Preemptive. So when we deal with the CPU scheduling algorithm, we need two kinds of concept, preemptive versus non-preemptive. Non-preemptive means no cycle, new, ready, running, terminating. And in preemptive, new, ready, running, waiting, ready, running, waiting, ready, running, terminating kind of things, or new, ready, running, interrupt, ready, running, interrupt, ready, running, interrupt, then terminating. This is the primitive sequence. So we have here total 2 sequences that we have talked about. Now, we are going to discuss about the performance criteria of CPU seedling. Whenever we make any CPU seedling algorithm, then performance of that algorithm should be evaluated. And these are the listed criteria to evaluate the performance of any CPU seedling algorithm. The first one is the CPU utilization, second one is the throughput, and when we talk about third one, this is the turnaround time, waiting time, and response time. So we need to evaluate all these criteria. So based on that, we can claim that which particular algorithm is best, which one is worst, kind of ranking we can apply based on these criteria. So first one, CPU utilization. So our goal should be CPU should be 100% busy. 100% utilization of the CPU we want. I mean, CPU should not be idle. So we have to design CPU seedling algorithm in such a way that CPU should be always busy. I mean, if you have input output operations, then CPU should work on the another process at the same time. CPU should not be idle. So we can claim that if CPU is working, all the time, there is no idle time, then utilization is 100%. So our desirable condition is 100% utilization of the CPU. So we need to design CPU seedling algorithm keeping this concept in mind. Second one is the throughput. Throughput is basically termed as how many processes are running in per unit of time. Say 5 processes are running per unit of time, then throughput will be 5. Say 10 processes are running per unit of time, then throughput will be 10. So our second criteria is maximum number of processes should be executed in per unit of time. This concept is called the throughput. So whenever we are designing any CPU seedling algorithm, we need to keep this thing in mind. Throughput should be maximum. And third one is the turnaround time. Turnaround time is the very important criteria to evaluate any CPU seedling algorithm. So turnaround time means basically time between submit the job and getting the result. Whenever process is assigned and when it is executing, whenever process comes into RAM and when it successfully executes, so this gap is called the turnaround time. Say for example, process comes at say 1:24 and completely executes at 7:26. So you can say that submitted at 7:26 and process is getting the result, final result at 7:26, then 2 seconds is the turnaround time. So this is the very important criteria. So whenever we design any CPU seedling algorithm, so we need to focus on average turnaround time. Fourth one is the waiting time. So waiting time means process in the RAM and it is waiting for CPU. This time is called the waiting time. Since we have the multiple processes in the RAM, as we are talking about the multiple multi-programming operating system. So, multiple processes reside in the main memory and CPU works only one process at one time. The rest of the process may be in the waiting state. So, waiting time is very important, and our desirable condition, our condition is here, this waiting time should be minimum. So, further we compute here average waiting time. Say you have 5 processes and we need to compute the average waiting time. So, our waiting time, our average waiting time should be minimum. Last condition is the response time. So, whenever we are talking about the interacting system, then lot of interaction is made between user and program. So, in the interactive system, we evaluate when first response comes. If we compute the turnaround time, then this is not a good criteria, because your process is waiting the response which will be given by the user. Say user giving the response immediately, your process will be execute immediately. So, here we need to wait on the response time, when first response is coming. For example, in C programming you have written enter the value of A, printf enter the value of A. So, when you are giving the first response, when this message is coming, enter the value of A, this is the first response. Computer is interacting, operating system is interacting, or process is interacting with you. So, when first response comes, this term is called the response time, and ultimately our response time should be minimum. So, whenever we are dealing with any CPU scheduling algorithm, we need to focus on these 5 criteria, and based on that we can tell which CPU scheduling algorithm is good, which one is best, or which one is worst, like this. This is all about the CPU performance criteria, scheduling performance criteria and process states that we have discussed. Thanking you.